In the last video, we have seen variation of g due to altitude. So, altitude is height above the Earth's surface. Now, here we will discuss variation of g due to depth. Now, when I say depth, that means I am going below the Earth's surface. So, suppose if this is my Earth, okay, then I am digging a hole and I am going at some point here. Okay, now this is the center of Earth, and from here to here it is the radius of Earth. Below the Earth's surface, okay, this distance is, let us call this distance d, correct? So then what is the effective distance between the center of Earth and the mass which is kept over here? Is it not r minus d? But now here what is going to happen is my effective sphere, okay, it is going to be something like this. Okay, here we are going to do an assumption that Earth is a fairly homogeneous mass, okay, with certain density. Now suppose density of Earth is rho, then rho is equal to mass upon volume. Density is equal to mass upon volume. Now what is the volume? Volume of a sphere is 4 upon 3 pi into r cube. So for this condition I am writing something here. So m upon 4 by 3 pi r cube, correct, and that is equal to rho. So obviously mass of Earth, okay, mass of Earth is 4 by 3 pi r cube into rho. Now what about mass of this sphere? Now this sphere is smaller, correct? A smaller sphere is going to attract this mass now, okay? So that mass, if I call that mass, let us say m1, that would be 4 by 3 into pi, and this radius over there, the radius of that smaller sphere is r minus d, and the cube of that, and that multiplied by rho, correct? Now again I am going to have, now I want to find the acceleration due to gravity at that point here, correct? So I am going to call that as g suffix d. In my earlier case it was g suffix h, correct, and it is going to be g m1 upon r minus d square, right? Now let us take a ratio of this with this, correct? So gd upon g is going to be equal to, now over here I have to substitute this mass m1, correct? So it is g into 4 by 3 pi into rho and r minus d cube, correct, and divided by r minus d square. And now that divided by this g, correct, it is going to be, what is my mass? 4 by 3 pi r cube, and that divided by r square, correct? So that is what we get here. I hope this is not very confusing. Little space constraint over there, but then I can cancel this out. I can cancel this 4 by 3 pi here. I can also cancel this rho over here, right? My r minus d square gets cancelled with this cube sign, okay, and this r square gets cancelled with this cube sign here. So what is the result? What am I left with? I'm left with only r minus d on top and r minus d and r, only r over here, right? So now that comes to 1 minus d upon r. So it is gd upon g is this. Now, so if I want to find gd here, that would be g multiplied by 1 minus d upon r. Now again, if the value of d increases, this ratio d upon r, that will increase, and then 1 minus d upon r would reduce. So that means as I go deeper and deeper, my value of acceleration due to gravity, it is going to decrease. So now what is the conclusion? Now I'm just going to remove this. Let us draw some conclusion on our findings in variation of g due to altitude as well as depth. So as my h increases, my gh decreases. As d increases, that means I'm going down and down and down, my gd again decreases, correct? My gh was equal to g into 1 minus 2h upon r, and gd is equal to g into 1 minus d upon r. Now in this second expression, if I reach center of earth, so that means my small d becomes equal to radius of earth. So in that case, the acceleration due to gravity is going to be equal to 0, correct? And what about this? Over here, when will gh become 0? It will be 1 minus 2h upon r becomes 0, right? So now let us talk about how the graphs will be seen. Okay, so that means one thing is there, acceleration due to gravity is going to be maximum on the surface of earth. As you go up, it is going to decrease. As you go down, it is going to decrease. So now here, okay, here I am on earth's surface, okay, my acceleration due to gravity, it will be equal to this value, that is g, correct? As I am at the center of earth, it is going to be 0. As I come to the surface of, now this graph is linear, okay, so it is going to be like this. So I reach this point. Now as I go further up, it is going to decrease. So the graph is going to be like this. So that was about effect of altitude and depth on the value of acceleration due to gravity. In the next video, we are going to talk about effect of latitude on acceleration due to gravity.